cornflakes, well, we already have the 4, so let's take that away. So 5 people like cornflakes only. These 4 like cornflakes and Cheerios. And over here for Cheerios, we know 5 like Cheerios. Well, 5 is everything in this circle, so we must subtract the 4. 5 minus 4 gives us the 1. So this question asks us both to draw this and label it. Really, we should have a title. So we could write favorite cereal, or we could write the cereals we like. Your title doesn't have to be very specific. It could be general. That would be okay. But the question we are asked for is how many people do not like Cheerios or cornflakes. So we're dealing with the people who are outside of these 2 circles. So the first thing to do would be to add up the number of people inside. 1 plus 4 plus 5. This equals 10. So there's 10 people who are inside these 2 circles, and this is called the union. 10 people live inside there. So if this survey asked 20 people, we would take away the 10, and that would give us 10. And so 10 people don't like these cereals. So we must write that. We can't just leave our answer as is. We must say 10 people don't like either cereal. And so that would be our answer to number 11. This is question number 12 that we are working on. Okay, so number 12 is asking us pretty much for definitions and examples. The first thing that it is asking us to do is to write about the associative property. So one thing that we could do is we could turn this into a table. Associative property of multiplication. And also there's an associative property of addition. So there are a couple of properties for associative. So if I grab this and I just try and turn this into a table, it's one line, and we have the other line. We could split it up this way as well. And not only is there an associative property of multiplication, but there is also a commutative property of multiplication and a commutative property of addition. These properties only work for multiplication and addition. They do not work for division and subtraction. So let's just put some examples down. Associative property is all about grouping. So when we think associative, we think associates, we think friends, we think our group. So this is a good word to think about when we are dealing with these properties, grouping. When we think about the commutative property, we think commute, going from A to B and B to A. So we're thinking about switching. And so these words really help me remember which is which. So for grouping, we could have A plus B plus C. In fact, this is multiplication, so let me undo that. We could have A times B times C. And if we could group them this way, with the A and the B in parentheses, or we could group them the other way, A times B times C, but we are grouping the A and the, we are grouping the B and the C together this time. So notice the A, B, and the C are in the same order, A, B, C. Over here, A, B, C. The only thing that is different are the way that they are grouped. So if this was numbers and variables or anything else, it would be the same. 2 times 3, and then times this by 5 is exactly the same as doing 2 times, but first doing the 3 times the 5. So notice the numbers are in the same order, 2, 3, 5, 2, 3, 5. But the parentheses are grouping those numbers in a different way. So that was the associative property of multiplication. So the associative property of addition is very similar, except we're adding. So it would be A plus B in parentheses, and then add C, is exactly the same as A plus B plus C. And so if we were to use numbers, then we could do 2 plus 3, and then add the 5 is exactly the same as 2 plus 3 plus 5. And we can prove it. If we do PEMDAS first, and we look at parentheses, 2 plus 3, well that would be 5, and then add 5, that would give us 10. Likewise, over here, if we do the parentheses first, we get 8, the 3 plus the 5, and then if we add the 2, we get 10 again. This was the associative property of addition. Remember, parentheses means they are grouped differently in this case. So the parentheses help us group differently. Okay, let's take a look at the next property, which is the commutative property. And we already said switching. So for multiplication, it means that A times B is exactly the same as B times A. Notice that we just switched them around. Also, we only have 2 variables here. We could have more and we could switch them in different orders, but really that's using 2 of them is the easiest way to show it. Alright, so if we were to use numbers, this would be the same as 4 times 3. That would be the same as 3 times 4. In either case, we end up with 12. That was the commutative property of multiplication. Okay, let's try the last one on our table. This is a commutative property of addition. So A plus B is exactly the same as B plus A. Again, we're just switching. So, let me just undo this. If we use real numbers over here, then okay, if we use real numbers over here, we could use the same numbers. 4 plus the 3 equals the same as 3 plus 4. In either case, it equals 7. Now we're almost through with this question, but it also asks us about the distributive property. Distributive property. So the distributive property, oh my gosh, that's a mess. Okay, distributive property, that's a P. Really, the key word here, or the key words, are to multiply out. Multiply out. Okay, and so what I mean by multiply out is that if you have something that looks like x times by 2 plus y, this means x times everything inside. So if we're multiplying this out, it would mean what we need to do is take the x and multiply it by the 2. And then take the x again and multiply it by the y. And because we're adding, then that would also stay. So here is exactly what I mean. X times 2 is 2x. And then x times the y is xy. We can't combine these terms. They are completely different. So we must write them as xy. And in the middle, because this is positive x and that's a positive y, and we are adding them, the addition stays. So if we were just to use numbers to show the distributive property, it would be the equivalent, the same as showing 3 parentheses, 5 plus, in fact, let's change that plus to a minus. 5 minus 2. Let's just show that it still works when we are subtracting. Well, again, we have to do the 3 times the 5, so 3 times 5, and then subtract, in this case, 3 times 6. So we could work this out. We could do, in fact, I made a mistake. Not 3 times 6, 3 times 2. Okay, because we got the 3 times the 5, which is 3 times 5, and then we have 3 times the 2. So 3 times 2 would be 6. So we could do 15 subtract 6, but we don't need to. If we're only asked to show the distributive property, this is exactly what we'd write. This is what we'd write for the commutative property of addition. This is the associative property of addition. This is the associative property of multiplication. And finally, this is the commutative property of multiplication. Number 13. Again, this is all about definitions. Sometimes it might ask you for examples. So I'm just going to use examples, but I'm going to talk about it. So we're asked for a whole bunch of things. We're asked firstly for a binomial. So bi means 2 and nomial means name, word, term, that type of thing. So here's an example of a binomial. 2x minus 1. Because right here we have two terms. We have the 2x, it's one term, and we have the minus 1, and the 1 is the other term. So a binomial is two terms. We cannot say that 2x plus x is truly a binomial because these are like terms. This should be written as 3x. And 3x on its own is what we call a monomial. So it's an O. Monomial is one term. So 3x would be an example of one term. Okay, 3x is an example of one term. Another example of a monomial would be 5. 5 is also one term. Another example of a binomial would be 10 plus 3xy. Because 3xy is still one term. It just contains two variables and a coefficient, but it's still one term here and one term there. Okay, so negative a half is also a monomial. Also, 7xyz is also a monomial because it's just one term. Okay, next thing that we might be asked for is a trinomial. Trinomial, tri means 3. Mono means 1, and bi means 2. So a trinomial is something with 3 terms. Now, the thing above, the 7xyz has 3 variables, but not 3 terms. So we've got to be careful not to confuse these. A very good example of a trinomial is something like 3x squared minus 2x plus 2. Now notice that we have an x here and an x there. These x's cannot be combined because the exponents have a different number. This is just x to the invisible 1. This is x squared. But this thing does have 3 terms. Here's the first term. Here's the second term. And here is the third term. So this trinomial